Welcome to the High Voltage Artificial Intelligence Podcast.
We're excited you're joining us for the deep dive today. This deep dive, it's actually part of a week-long series we've been running in the PXRD newsletter on Substack. It's tailored specifically for electric utility engineers like you. All week, we've been exploring how FERC, that's the Federal Energy Regulatory Commission, Order 1920 is, well, fundamentally transforming transmission planning and design across the country.
Exactly. Yeah, we kicked off the week on Monday just explaining FERC Order 1920's basic requirements, foundational stuff. Then Tuesday, we jumped into those 7 benefits, the ones changing how you'll evaluate projects. Wednesday was all about the 20-year planning horizons engineering for 2045, essentially starting today. And then yesterday, Thursday, we looked at grid-enhancing technologies, new planning toolkit, basically.
So today is Friday, and we're pulling it all together. We're focusing on something that directly impacts you, your day-to-day and your future. Career impact, how FERC Order 1920 creates new engineering opportunities.
Mm-hmm.
Because this transformation, it isn't just about regulations, right? It's really reshaping the entire landscape of utility engineering.
That's fascinating. And, something that really jumped out at me from the research was this specific example. Just last month, Xcel Energy posted a role for a multi-benefit transmission analyst.
Mm-hmm.
That job title literally didn't even exist 2 years ago.
Mm-hmm.
And get this, they got 247 applications in the first week. Is that the kind of concrete evidence we're talking about, these new opportunities?
Absolutely. Yeah, the Xcel example, it's not an outlier. It's a really clear signal. FERC Order 1920 has basically created whole new categories of transmission engineering roles, and it's also changing the existing ones quite profoundly. So our mission today in this deep dive is to pull out the most important nuggets for you, understanding how these changes are reshaping careers, what specific skills utilities are looking for now, and how you can position yourself to really grab these opportunities because they are unprecedented.
Okay, so given all these shifts, you might be thinking, well, what do these new career paths actually look like? Are we talking totally new job titles? Let's maybe start with what seems like the most direct result of Order 1920, these multi-benefit analysis engineers.
That's a great place to start. Yeah, these are the engineers who are quantifying those 7 specific benefit categories. And they're doing it across those new 20-year planning horizons for transmission projects. So their key responsibilities: calculating reliability benefits, economic ones, capacity, policy benefits. It involves a lot of production cost modeling, market simulation too. What's really insightful, I think, is how these roles aren't just about the engineering calculations. They're fundamentally changing how utilities quantify value, how they make investment decisions. It's moving beyond just reliability, to a more holistic, financially driven view.
Okay, so quantifying value for decisions, that makes sense. What about the time frame, that 20-year horizon? Who's actually building out those long-term scenarios that FERC Order 1920 is demanding now?
Good question. That's where your scenario planning specialists come into play. These engineers, their job is developing and, importantly, maintaining these complex scenario frameworks for that long-range planning. They're creating plausible future scenarios, getting a lot of stakeholder input, combining climate projections, economic forecasts, technology trends, and they have to make sure it's all consistent across different planning models. A big part of their work is also probabilistic analysis, things like Monte Carlo simulations to handle all the uncertainty. And this is where we're seeing some really cutting-edge specializations pop up too, like climate integration analysts, technology forecasting engineers, even policy analysis engineers.
Wow, okay, that's a whole new vocabulary of engineering roles being created right there. I can imagine for some traditional engineers, it might feel a bit like trying to navigate a new city without a map. Speaking of new things, how is FERC Order 1920 driving demand for engineers who specialize in grid-enhancing technologies, GETS?
Oh, it's creating a major specialization, the GET engineer. Grid Enhancing Technology Engineer. These are the folks evaluating, designing, and implementing these GET solutions. And within that, you've got subspecializations like dynamic line rating engineers. They work with real-time weather data, thermal analysis to squeeze more capacity out of existing lines safely. Then there are FACTS application engineers, that's flexible AC transmission systems. They're focused on the power electronics, the control systems for these advanced devices. Plus, you've got advanced conductor specialists, transmission switching analysts, the core technical skills. You need power electronics, control systems, material science, optimization. And on the implementation side, strong project management is crucial for these unique projects. Vendor management, performance analysis too. Demand is, It's very high because
Well,
there just aren't that many people with deep experience here yet.
that makes perfect sense. Yeah, implementing these new techs needs a very specific mix of skills. And with planning now stretching across multiple states, who's handling these bigger, more complex regional processes?
Right, that responsibility falls to the regional planning coordinators.
Right.
These engineers are managing the multi-state transmission planning processes that FERC Order 1920 mandates. And their responsibilities are, frankly, huge. Managing joint planning across different utilities, dealing with multiple state utility commissions, figuring out regional cost sharing, and facilitating these really complex negotiations with all sorts of stakeholders. So these roles demand a deep grasp of regional transmission systems, obviously, familiarity with FERC and state regulations, and critically, top-notch negotiation and conflict resolution skills.
Okay, so we've got these brand new roles emerging, which is exciting. But what about the traditional engineering roles, the ones that have always been the backbone of utility operations? How is FERC Order 1920 changing those jobs? Let's maybe start with transmission planning engineers.
Yeah, they're seeing a really profound evolution. Traditionally, their focus was, load flow analysis and -1 contingency planning, which is basically making sure the grid stays stable even if a major piece of equipment fails, right? Plus equipment sizing, substation design. But now, with FERC Order 1920, their roles are enhanced. They have to do multi-scenario analysis over those 20-year horizons. They have to calculate all 7 benefit categories we talked about earlier. They need to assess grid-enhancing technologies. It's mandatory. And they're involved in multi-state planning, complex cost allocation. So this means new skills are required. Things like economic analysis, market simulation, advanced analytics for handling uncertainty, understanding policy integration. And the data shows engineers who pick up these FERC Order 1920 skills, they can see maybe a 15 to 25% salary bump.
Okay, and what about protection and control engineers? How are they being affected by all this integration of new grid-enhancing technologies?
Their world is changing dramatically, too. I mean, traditionally, they focused on protective relay settings, control system design, SCADA systems, supervisory control, and data acquisition communications. But GET integration, it demands totally new capabilities. Think about integrating dynamic line ratings so protection systems get real-time updates, or coordinating FACTS devices. Even things like adaptive protection settings that automatically adjust based on how the grid is configured at that moment. This is actually leading to new specializations within P&C, like GET protection engineers or adaptive protection specialists. And there's a much bigger need now for communication system engineers and cybersecurity engineers, too, especially thinking about NERC CIP compliance. That's the critical infrastructure protection standards.
And then there are the system planning engineers. Their traditional approach often seemed based on those maybe 10 to 15-year deterministic forecasts. How is Order 1920 changing their whole strategic planning game?
Oh, it's a complete paradigm shift for them. Yeah, the old way was shorter horizons, 10, 15 years, deterministic analysis, often just one scenario, usually very utility-specific planning, minimal regional coordination, really focused on reliability above all else. FERC Order 1920 flips that script. You've got the extended 20-year horizons, mandatory use of multiple scenarios. They now have to use probabilistic methods like Monte Carlo simulations to account for uncertainty. They're neck deep in multi-state planning, benefit allocation, performing multi-benefit optimization. So they're enhanced responsibilities. Developing and maintaining multiple complex planning scenarios, incorporating sophisticated market analysis into their decisions, it's a much bigger job.
So, okay, with all these changes, all these new opportunities, the big question for our listeners has to be, how can you actually develop the skills you need to thrive in this new landscape? Let's maybe break it down by career stage. What about recent engineering graduates just starting out?
Yeah, good plan. For those in their first, say, 1 to 3 years, the focus really needs to be on building a super strong foundation. That means a solid grounding in transmission analysis, power systems fundamentals. Also, microeconomics and electricity market basics are becoming crucial. Statistical analysis and programming Python, R, MATLA for data analysis. That's huge now. And maybe overlooked sometimes, but really important, sharp communication skills. Technical writing, presenting complex ideas clearly.
That sounds like a really solid base. What about folks who are mid-career, maybe 3 to 7 years in, looking to specialize?
Right, so years 3 to 7, that's really the specialization phase. You need to choose a primary focus area. Is it multi-benefit analysis? Scenario planning, grid-enhancing technologies, regional coordination. Pick one. Then aim to get your professional engineer PE license, if you haven't already, and look into relevant industry certifications. Seriously consider a Master of Science, maybe in power systems, maybe economics, maybe policy. Depends on your focus. And get active. Join IE, the Institute of Electrical and Electronics Engineers, or CIGRE, the International Council on Large Electric Systems. Go to industry conferences. Then, looking ahead, after year 7, think leadership prep. Project management professional, the PMP certification, leading complex projects, maybe an MBA or executive education for strategic thinking, getting involved in committees, mentoring junior engineers, that's all key too.
And for those mid-career engineers you mentioned, the pathway seems to start with a pretty honest self-assessment. What should they focus on in those first 6 months?
Exactly. First 6 months. Figure out your FERC Order 1920 skill gaps. Where are you strong? Where do you need work? Understand what your local utility is prioritizing and hiring, what the salary ranges look like. Connect with people already working in the specializations you're interested in. LinkedIn, conferences, internal contacts. And then based on all that, develop a clear 12 to 18-month skill development plan. Then, the next 6 to 18 months, that's targeted skill building. Take courses, electricity markets, economic evaluation, get proficient in statistical software. Go to vendor training sessions for specific grid-enhancing technologies. Work on your presentation and facilitation skills. And finally, maybe 12 to 24 months out, start making the transition. Apply for those FERC Order 1920 related roles, internally or maybe externally. Consulting roles are another option. They often need this expertise. Or pursuing advanced degrees or certifications you identified earlier.
Okay, and what about our senior engineers and managers? How do they strategically position themselves? They're already established.
For them, it's more about strategic positioning and thought leadership. This means things like publishing articles, speaking at conferences about FERC Order 1920 topics, showing expertise, leading your utility's internal implementation strategy for Order 1920, that's a big one, mentoring those junior engineers, helping build internal capabilities, participating in developing industry standards and best practices, and for executive preparation. Focus on strengthening financial and strategic planning skills. Get a really deep understanding of FERC and state regulatory processes, hone those advanced multi-party negotiation and facilitation skills, and demonstrate experience leading big organizational change initiatives.
Now let's talk geography. Where are these jobs actually popping up? It sounds like some regions are hotter than others, like Texas, right? ERCOT territory. Massive renewable growth. Data centers booming. They seem focused on scenario planning, renewable integration specialists, and the salaries there reflect that demand, maybe a 10 to 20% premium over the national average.
That's exactly right. Texas is a major hotspot. California, too. CAISO. Driven by really aggressive climate goals, wildfire resilience needs. So they're hiring climate integration specialists, GET engineers. The salary premium there is even higher, maybe 25 to 35% above average, but you have to factor in California's cost of living. Then there's the PJM region, Mid-Atlantic, parts of the Midwest. Huge transmission queue, really complex regional coordination needed. So they're looking for multi-benefit analysts, regional planning specialists. Premium there is maybe 5 to 15%. And the Northeast ISO, New England, NYISO. Lots of offshore wind integration, big electrification policies. They need renewable integration folks, economic analysis engineers. Salary premiums similar to California, maybe 15 to 25%.
Okay, so those are the big hot spots. But
Yeah.
are there other areas, maybe emerging opportunities?
Yeah, definitely. The Southeast region, for instance, growth there is really being driven by data center development, industrial electrification. It's more of a ground floor opportunity in some ways as utilities there build up their FERC Order 1920 capabilities. Think Southern Company, Duke, Dominion, TVA. Similarly, the Mountain West. Lots of renewable resource development needing transmission expansion. Opportunities there are often in scenario planning for integrating all those renewables. Plus, you get experience with long-distance transmission, managing variability. Companies like Xcel, Rocky Mountain Power, APS.
All of this points to some pretty significant shifts in salaries and compensation.
Yeah.
Let's dig into the numbers a bit, because this is where the rubber meets the road for a lot of people. For entry-level engineers, 0 to 3 years. A traditional planning engineer might be, $75K to $95K? But a multi-benefit analyst, even entry-level, could be $85K to $110K. And a GET engineer, $80K to $105K. That's like a 10-15% premium for having those Order 1920 skills right away.
That's what the data suggests, yes. The premium is real, even early on. And it grows with experience, mid-career, 3 to 10 years. A senior planning engineer might be $100 to $130K. But compare that to a scenario planning specialist at $120K to $155K, or a GET application engineer, $115K to $150K, a regional coordinator, $125K to $165K. Then at the senior level, 10 plus years. Principal engineer, maybe 140K to 180K, but a manager of economic analysis could be 160K up to 220K, director of regional planning, 180K to 250K, technology director, 170K to 240K range. And remember those geographic adjustments we talked about? California and New York adding 25-35%, Texas, PJM adding 10-20%, Southeast, Mountain West baseline. Smaller utilities might be 10-15% below average.
Those salary premiums are definitely eye-catching. But, for engineers looking to make this jump, what are some of the biggest challenges they might face in actually acquiring these new highly paid skills? Is it just about, say, taking a course online, or is the learning curve steeper than that?
Oh, it's definitely more than just taking one course. The skill premium analysis really breaks it down. Having economic modeling skills. That could add $10,000 to $20,000 to your annual salary. Scenario planning expertise, maybe $15,000 to $25,000 extra. GET expertise is worth an extra $12,000 to $22,000. Even strong stakeholder management skills command a premium, maybe $8,000 to $15,000. These aren't just, technical add-ons. They often require fundamentally new ways of thinking, analyzing data, collaborating across disciplines. So yeah, there's a learning curve.
It sounds like the investment in learning really pays off, though. So if you're ready to make that investment, what are the best professional development resources out there?
Good question. There are quite a few pathways. For industry training, FERC itself holds regular technical conferences. Those are great for updates on Order 1920 implementation. The IEE Power and Energy Society offers a lot of training courses, even certifications. CIGRE study committees are excellent for tapping into international best practices. And the EEI Engineering Conference, that's Edison Electric Institute, is really good for utility-specific training and networking.
Are the universities keeping pace with these new demands? Are there specific programs?
They are, absolutely. Georgia Tech, for example, has a Master of Science in Electric Power Systems that specifically focuses on FERC Order 1920. UC Berkeley's Energy and Resources Group is fantastic for the policy integration side. MIT has strong programs in economic analysis and energy markets. Virginia Tech has a specialization in grid-enhancing technologies. And don't forget vendor training. That can be really valuable. PLES for production cost modeling, PowerWorld University for advanced transmission planning. Siemens, GE, ABB offer training on their FACTS devices. Lindsay Manufacturing for dynamic line rating systems. That hands-on training is key.
Okay, and thinking about certifications credentials. Beyond the PE license, which is still fundamental, right? What else is becoming important?
Yeah, the PE license is still table stakes for many roles. State requirements vary, needs continuing education. Some states even have power systems specialty PE exams now. Beyond that, NERC certification, like system operator or planning coordinator, is very valuable. The PMP certification for leading these complex projects we've talked about. For roles heavy on financial analysis, maybe a CFA or FRM could be relevant. And for data analytics, certificates in Python, R, or advanced statistics are becoming highly sought after. We're also seeing emerging credentials, things like grid modernization certificates, energy policy analysis credentials, even vendor-specific GET certifications. And don't underestimate certifications in professional facilitation or negotiation for those stakeholder-heavy roles.
Okay, so how do you pull all this information together? How do you actually build your FERC Order 1920 career strategy? It sounds like it really has to start with a serious self-assessment.
Exactly. You got to start there. Do a technical skills inventory. Honestly, rate your current abilities in transmission planning, economic analysis, analytics like statistical modeling, and specific technologies, especially GETS. Then do a professional skills assessment. How are your communication skills, especially presenting complex stuff? Your project management skills, particularly leading multi-stakeholder projects. How strong are your stakeholder management skills, facilitation, negotiation, conflict resolution? And finally, what's your level of regulatory knowledge? FERC, state regs, policy processes.
That self-assessment sounds crucial. Okay, so once you have that baseline, how do you prioritize your development? Maximize the impact.
Right. Then you can create a kind of development priority matrix. Think about impact versus effort. High impact, high effort moves. Things like pursuing an advanced degree, MS or PhD, getting a major certification like the PE or PMP, aiming for industry leadership committee chair, publishing papers, or even relocating to a high demand region. Then there's high impact, low effort. Things like targeted software training, PXOs, grid views, statistical tools, attending the key conferences, IEEPE, CIGRE, EEI, Focus professional networking, just staying current by reading technical papers on Order 1920. And maybe avoid low-impact, high-effort stuff like tangential training that isn't directly relevant, or just networking without a clear goal.
Okay, to make this really concrete for listeners, could you maybe sketch out a practical 12-month action plan? Someone ready to dive in, what should they do?
Sure, let's try a template. Months 1 to 3, focus on foundation. Complete that skills assessment and gap analysis. Research target roles, salary ranges. Start some software training, Plexos or PowerWorld maybe. Join relevant professional groups. Months 4 to 6, skill development. Complete your first major training program, maybe economic analysis or a GET technology. Attend a major industry conference. Start actively networking in your target specialization. Try to get involved in an internal project that touches on Order 1920 concepts. Months 7 to 9. Application. Start applying Order 1920 concepts in your current job, if possible. Volunteer for cross-functional teams or committees related to this. Present your work at internal meetings, maybe even external ones. Build a portfolio showing your Order 1920 related work. Months 10 to 12. Positioning. Now you start applying for those target roles, internal or external. Complete any advanced certifications or training you planned. Maybe publish a technical article or a conference paper. Really work on establishing yourself as a knowledgeable person in your chosen specialization. So wrapping it all up, what does this all mean for you listening? FERC Order 1920, it really is more than just another regulation. It's actively creating entirely new kinds of engineering careers, ones that blend that traditional power systems expertise with economics, policy, advanced analytics.
Right. So here's the bottom line. Maybe some key takeaways for your career. First, timing advantage. If you start developing these FERC Order 1920 skills now, you could have 3, 4, 5 years of valuable experience right when demand really peaks. Second, skill convergence. The most valuable people, the ones getting the highest compensation. They'll likely be those with hybrid skills. Engineering, plus economics, policy, stakeholder management. Those skills are rare right now. Third, geographic mobility. These skills aren't tied to one specific place. They're transferable across different regions, giving you flexibility and more paths for advancement. Fourth, compensation premium. We saw the numbers. Expect significant salary premiums, maybe 15 to 30%, because the supply of qualified candidates is low and utility demand is high. Fifth, long-term security. These skills aren't a flash in the pan. They'll be relevant throughout these 20-year planning horizons. That provides real career stability. And sixth, growth trajectory. New specializations are popping up faster than universities can even create programs for them. That creates unique opportunities if you're willing to pursue self-directed learning.
Exactly. The engineers who really master these FERC Order 1920 competencies, they won't just be advancing their own careers, they'll actually be shaping how our transmission system evolves over the next 2 decades. So the real question isn't if these changes will reshape utility engineering careers, it's whether you will position yourself to benefit from this massive transformation.
So as we wrap up this week-long series, maybe ask yourself, what FERC Order 1920 related skills are you actively developing right now? Are you starting to see these new career opportunities emerge at your own utility?
And looking ahead, next week we're kicking off our Emerging Technologies series. We'll be diving into topics like nuclear small modular reactors, grid-forming inverters, artificial intelligence and grid operations, and advanced protection systems. Definitely tune in for those deep dives.
If you'd like to leave feedback or have any questions about today's deep dive or the whole series, please feel free to reach out. I'm at alex.reed.power.podcast@gmail.com.
And I'm at emma.quinn.power.podcast@gmail.com. Thanks so much for joining us for the deep dive.